For nearly a century, the edge of our solar system was envisioned as a desolate graveyard of frozen relics. At the farthest reaches of the sun's domain, nearly 3 billion miles away, a tiny world orbited in the perpetual twilight of the deep cosmos. This was Pluto, a celestial body discovered as a faint wandering speck of light, long assumed to be nothing more than a geologically dead sphere of ice and rock. Yet the universe harbors a profound capacity to shatter our assumptions. The question of what truly existed in that distant, frigid darkness haunted astronomers for generations, inspiring endless theoretical debates. It was a profound mystery that demanded an audacious answer, setting the stage for one of the most ambitious endeavors in the entire history of space exploration. The journey to unveil this distant enigma would require pushing the absolute limits of human engineering, orbital mechanics, and scientific imagination, daring to reach where no instrument had ever gone before. In January 2006, humanity answered the compelling call of the outer solar system by launching the New Horizons spacecraft from the shores of Florida. It tore through the Earth's atmosphere at unprecedented speeds, embarking on a colossal voyage that would take nearly a decade of silent transit to complete. This robotic emissary was meticulously designed not just to reach a distant, unseen target, but to fundamentally rewrite our foundational understanding of the entire cosmic neighborhood. Surviving the harrowing journey across the vast, empty expanse of interplanetary space demanded remarkable technological resilience. Sunlight in the outer solar system is too weak to power solar panels, so the spacecraft relied on a radioisotope thermoelectric generator, drawing electricity from the natural decay of plutonium. This steady nuclear heartbeat kept the instruments alive as the probe sailed silently through the freezing void. The sheer scale of the transit required the spacecraft to spend long stretches in electronic hibernation, conserving precious energy while ground controllers on Earth monitored its quiet pulse. Navigating across billions of miles to intercept a target smaller than Earth's moon required orbital mechanics of staggering precision. A fraction of a degree in error could mean missing the encounter entirely, sending the probe helplessly into the endless interstellar abyss. In the summer of 2015, the long technological slumber ended, and the destination finally began to resolve against the sprawling backdrop of the Milky Way galaxy. What had once been merely a blurry, pixelated blob in the powerful lenses of the Hubble Space Telescope slowly transformed into a distinct, astonishingly complex world. The breathtaking approach alone began to systematically dismantle decades of established planetary theory, preparing scientists for an unprecedented revelation. As the spacecraft executed its historic flyby on July 14th, the first high-resolution images beamed back to Earth sent shockwaves through the scientific community. There, spanning the equator of this distant world, was a massive, brilliant feature shaped remarkably like a heart. This stunning geological formation, later named Tombaugh Regio, was a pristine expanse of highly reflective ice, glowing against the darker, cratered terrain surrounding it. Researchers discovered that the western lobe of this heart, a region known as Sputnik Planitia, was a vast, sprawling plain of frozen nitrogen. But it was not a static, frozen wasteland. The surface was entirely devoid of impact craters, a staggering revelation that indicated the landscape was remarkably young. Somehow, in the coldest depths of the solar system, the surface was constantly renewing itself. The nitrogen ice plains were segmented into bizarre polygonal convection cells, slowly churning and turning over like thick oatmeal boiling on a stove. This slow-motion geological ballet is driven by a faint internal heat source, pushing warmer nitrogen ice to the surface while colder, denser material sinks along the edges. Such active geology was thought utterly impossible for a world so small and so far from the warming embrace of a star. Bordering these smooth plains, the spacecraft revealed towering, jagged mountain ranges reaching thousands of feet into the thin, hazy atmosphere. These peaks, however, were not made of silicate rock like the mountains of Earth, but of solid, rock-hard water ice. At temperatures plunging below -380 degrees Fahrenheit, water ice becomes as strong and rigid as granite, capable of supporting immense topographical structures. The existence of these massive ice mountains and churning nitrogen plains forced scientists to confront a startling paradigm shift. The internal heat required to drive these processes could not be generated by gravitational tidal forces, as is the case for the active moons of Jupiter or Saturn. Instead, the energy likely stems from the slow radioactive decay of elements deep within the rocky core, a remnant of the solar system's turbulent formation. This realization gave rise to a profound hypothesis that continues to tantalize researchers today. Beneath the frozen crust, insulated by the thick layers of ice, there might exist a deep, global subsurface ocean of liquid water. The idea that a subterranean ocean could survive on a world traversing the Kuiper Belt dramatically expands the potential habitable zones within our galaxy, challenging our definitions of where the fundamental building blocks of life might persist. The stunning revelations extended far beyond the primary body, encompassing its intricate gravitational dance with its largest moon, Charon. The two distinct worlds are locked in a highly unusual binary system, orbiting a common center of mass that lies suspended in the empty space between them. They face each other perpetually, locked in a synchronous, tidal embrace that has fundamentally shaped the evolutionary history and geological architecture of both celestial spheres. Charon proved to be a world of stark, dramatic contrasts, completely distinct from its planetary partner. Its surface is fractured by a colossal system of canyons, stretching for hundreds of miles and plunging deeper than the Grand Canyon on Earth. This massive tectonic scarring suggests that the Moon once harbored a subsurface ocean of its own, which eventually froze, expanding and tearing the crust apart in a cataclysmic global rupture. Adding to the Moon's enigmatic character is its dark, reddish polar region, affectionately dubbed Mordor Macula by the scientific team. Scientists believe this crimson stain is composed of tholins, complex organic molecules synthesized from methane gas that escaped from the primary atmosphere and became trapped at the Moon's frigid poles. Over millions of years, relentless ultraviolet radiation from the distant sun baked these trapped gases into the dark, reddish compounds we see today. But perhaps the most astonishing discovery lay in the identification of massive, anomalous mountains featuring deep, plunging central depressions. These towering features, notably named Wright Mons and Picard Mons, are entirely unlike any traditional volcanoes found on the rocky terrestrial planets of the inner solar system. They are the unmistakable massive signatures of cryovolcanism, a bizarre process where icy magma, a slushy, freezing mixture of water, ammonia, and methane, erupts onto the planetary surface. These immense ice volcanoes do not explode with fiery ash and molten rock, but instead slowly exude freezing, viscous slurries that build up into towering domes over vast geological timescales. The discovery of cryovolcanism on this distant outpost provided undeniable proof that the interior is still dynamic, actively shaping the landscape in ways that parallel the volcanic activity of our own world, yet governed by completely alien chemistry. The redefinition of this distant world fundamentally altered our perception of the entire Kuiper Belt, a region previously shrouded in astronomical assumption. No longer could this vast, ring-shaped region of icy bodies be easily dismissed as a static, frozen junkyard of primordial planetary debris. It was now definitively revealed as a dynamic, active frontier populated by complex, evolving worlds that harbor their own unique geological mechanisms and profound internal mysteries. This transformation of perspective underscores a vital truth about human exploration. Every time we push our mechanical proxies further into the dark, the universe responds by revealing complexities that defy our most educated predictions. The boundaries of planetary science were pushed outward, proving that geological vitality does not end at the orbit of Neptune, but extends deep into the interstellar shadows. The legacy of that historic, paradigm-shifting flyby did not conclude with the rapid passage through the binary planetary system. The resilient spacecraft continued its relentless outward trajectory, plunging ever deeper into the uncharted, shadowy territories of the outer solar system. Its scientific mission was extended, its optical sensors and spectrometers primed to hunt for ancient, pristine remnants from the very dawn of our solar system's turbulent formation. On New Year's Day in 2019, the probe achieved another unprecedented milestone by intercepting Arakoth, a contact binary object located 4.6 billion miles from Earth. This strange, flattened, snowman-shaped relic offered an unblemished look at the primordial building blocks that coalesced to form the planets so long ago. It was a journey back in time, captured perfectly in the cold storage of the outer solar system. The data transmitted across those billions of miles, traveling at the absolute speed of light, took hours to reach the colossal dish antennas of the deep space network. Each byte of telemetry was a testament to the audacity of human ingenuity, a whisper from the void that carried the weight of a completely transformed cosmos. The sheer triumph of receiving complex geological data from such an extreme distance remains one of the crowning achievements of modern astrophysics. Decades of meticulous planning, engineering, and theoretical modeling culminated in a data set that will be analyzed by generations of scientists to come. The icy mountains, the churning nitrogen plains, and the fractured moons now stand as monuments to our relentless drive to understand the mechanics of the universe. We reached out to a tiny point of light and found a breathtaking, active world. As the spacecraft continues its solitary voyage toward interstellar space, joining the ranks of the Voyager and Pioneer probes, it leaves behind a profoundly altered scientific landscape. The boundaries of the known have been permanently expanded, and the dark reaches of the outer solar system are now recognized as a canvas of incredible planetary diversity. The cosmos is infinitely more creative than our initial theories ever allowed. Our journey to understand the universe is an endless pursuit, a continuous process of having our assumptions challenged and our horizons broadened. The revelation of active geology at the edge of our solar system serves as a powerful reminder that the cosmos is alive with dynamic processes, waiting patiently in the dark for us to build the tools to see them. As we look upward, we are no longer just staring into an empty void, but into a boundless frontier of active, evolving worlds.